Hello. This is in this video I will go over three main inverse trig integrals and go over the two half angle integration rules. So this is calculus 2 and this is inverse trig integrals. So yes. So let's go over the first three integrals of inverse trig functions or arc functions. So the first three are this. So go ahead and write this down in your note. So this is the inverse. The first one is the integral of 1 over square root of b squared minus parentheses ax parentheses square of dx, and that equals to this. So if you see a square root on the bottom and there's a minus in the middle, you know you're going to use this. It's 1 over a sine inverse of ax over b plus c. Okay, if your integral looks anything similar to this, where you have a 1 on the bottom and it's all over x times square root of ax squared minus b squared, your final answer will be in this. Okay, and you're probably, what if you didn't have a 1? Well, if you have a constant, you can always factor out a constant. So you try to make this look like a 1, right? If your integration problem looks anything like this, after you take out the constant, you have a 1 on the top, and then there's no square root in the bottom. It's just b squared plus ax squared dx. You know your final answer will be in this form. 1 over a over b times tan inverse of ax over b plus c. Okay, so those are the three inverse trig integration. And then there's only three inverse trig integration because the co-function are just the negative constants of those. So now let's talk about the half angle integration. So if your integration looks anything like this, integration of sine square ax dx, it's equal, your final answer shall be in this form. The integration of 1/2 minus 1/2 cosine of 2 times ax dx. If your integration looks anything like this, your final answer will be this. So if your problem looks like integration of cosine squared of ax dx, your final answer shall look like this. The integration of 1/2 plus 1/2 cosine times 2ax of dx. Okay, so go ahead and write that down. I think I'll write it again later on this lecture. So let's just let's evaluate some integrals. So example 1 says evaluate the integrals from 1 over square root of 1 minus 9x squared. So which one does this look like? Let's see, you have a square root on the bottom and then you have a minus in the middle. I think it's the sin inverse, right? Yes, it's this one. Because see, you have a square root and then there's a minus on the bottom. We're going to use that one. Okay. Here, I don't know why it does this. So we have the integration of 1 over square root of 1 minus 9x squared. We have a 1 on the top, so we don't have to factor out a constant. Sometimes you won't have a 1. You might have to factor out a constant. So it's going to look, we can rewrite this as so it's going to be what number is squared minus a number a number and x squared, so it'll be 3x. So what number squared gives you 1? It would be 1. So that means our b is equal to 1. And then be careful with this one. The a is not the x. You don't include the x. We want a 9. So what number squared gives you 9? 3. So our a is 3. And then you put it in the formula. We said that's going to equal to 1 over a sin inverse of ax would be plus c. Okay, we have everything we need. We have our a value and we have our b value. So our final answer will be 1/3 sin inverse of our a value, which is 3x, and our b is 1. And then don't forget the plus c because we have no boundaries. Pretty simple, right? Not too bad. You just need to know your formulas and you'll be good. Okay, so let's continue on. Let's move on to example 2. Evaluate the integrals from, this is -3 over square root of 4 minus 25x squared of dx. So I still believe it is this, I do believe it's still the 1 over sine inverse of ax over b plus c. The thing is, we have to make this into a 1, right? That's the only way it'll work. So what we could do is we could factor out this constant -3 and put it out in front of the integral. So now you have a 1 here, square root 4 minus 25x squared dx. Okay, so yeah, so this is going to be -3, 1 over square root. So what number squared gives you 4? That will be 2. Minus what number squared gives you 25? That would be 5. Okay, so that means our b is 2 and my a is 5. So put it all together, you get 1 over a, which is 5, sin inverse. Oh, so wait, our answer is going to be equal to 1 over a sin inverse of ax over b plus b. So that's going to be 1 over a, and our a is 5, sin inverse of ax. A is 5x, and our b is 2. Let's see. And what also, don't forget, we took out a -3. So you got to multiply this everything by -3, right? So your final answer will be -3 fifth inverse 5x over 2. Let's see. So now here we can, before we move on, these are the views of our integration rules. I think there's 9. So go ahead and write this down and pause if you need the video. Pause. There's rule 1, 2, rule 3, rule 4, rule 5, 6, rule 7, rule 8, rule 9. Okay, let's move on to example 3. Evaluate. We have the integration of 5 over 49 plus 16t squared dt. So the first thing, so I noticed there's no square root in the bottom. There's a plus right in the middle, so I know for a fact we might have to use the tan inverse. So we might have to use this. Well, we actually will. 1 over AB tan inverse of AX. over b plus c, right? So the thing is, we got to make this a 1. So to do so, you're going to have to factor out that 5. It's 1 over 49 plus 16t squared dt. And what could we do? So this is going to be, what's 49 squared? What number squared gives you 49? That'll be 7 squared plus, what number squared gives you 14t squared? That would be 4t squared dt. So we have our a, so I think our a is going to be, our b is 7, and our a is going to be 4. So now we just put in the formula. AB, a is 7, it's 4 times 7 times it by tan inverse 4x, because our a is 4, our b is 7, and this is going to be, also don't forget we took out a 5. The final answer is going to be 5 over 28 tan inverse of, oh, we're not in x's, we're in terms of t's, so it's going to be 4, instead of 4x, it's going to be 4t. Okay, there's your final answer. Okay, so let's move on to example 4. Example 4, evaluate the integration of 6 over square root of 7 minus 9y squared. So what do I notice? There is a minus in the middle. There is a square root in the bottom. There's a good chance we're going to use 1 over a sin inverse of ax or b plus c, right? So before I go any further, I got to make the numerator 1. So I have to get rid of this or move this 6. So you could, it's a constant, so you could put that right in the front of the integration rule. So yes, 6, and then square root, and uh-oh. So this one's a little bit trickier. What number when squared gives you 7? And what number, and this is easy, what number squared gives you 9y squared? It would be 3y. So yeah, what number squared gives you just regular 7? Well, I think that's radical 7, because radical 7 squared gives you 7, right? So yeah, that means our b is going to be square root of 7, and my a value is going to be 3. Okay, and then put it in the formula. So it's 1 over a sin inverse of ay over b plus c. And don't forget we took out a 6. It's going to be 6, and then it's 1 over a, just 3, sin inverse of ay over b. And my a is 3y, and my b is radical 7 plus c. So when you put this all together, 6 times 1/3 is 2. So that's 2 sin inverse of 3y over square root of 7. Let's see. Let's move on to example 5. Evaluate the integral. So we have a negative 1 over square root of 25 minus 2x squared. So what do I notice? There's a square root in the bottom. There's a minus right in the middle. So there's a good chance we're going to use the 1 over a sin inverse of ax over b. Let's see. So first step is get this into a 1, so we can factor out that -1. And then number squared minus the squared. So what number squared gives you 25? 5. Okay, this one, careful. What number squared gives you 2? I think that's going to be radical 2, because radical 2 squared gives you 2. So yeah, this is going to be radical 2x. So remember, your a is not doesn't your a is not involved with x. Your a is the constant. So the a is radical 2, and your b is 5. And then put it all together, so you put 1 over a, and then you put it in. So don't forget, we took out a -1. So it's 1 over a, which is radical 2. Then inverse of ax. A is radical 2, x, and our b is 5. Let's see. And then you may FOIL that minus, so that's going to be -1 over radical 2 sin inverse. Okay, let's move on to example 6. Example 6 says evaluate the integration from 2x plus 2 over 9x squared plus 5. So the first thing I can notice is there's two terms. So we can write out two separate integrals, right? So we can say the integral of 2x dx plus the integral of 2 over 9x squared plus 5 dx. Okay. This one's easy. The integral of 2x dx, that's nothing new. Like there's nothing fancy about it. It's just it's going to be 2x. This has a power of 1. So 1 plus 1 is 2 over 2, which is just x squared. This one, I noticed that in the bottom, there's no square root. There's a plus in the middle. So you're most likely you're going to use the tan inverse. So it's going to be 1 over AB and inverse of AX over B plus C. So first step is we got to get this 2 into a 1. So factor out that 2. And then figure out your A and your B. So I think our A, so this is going to be, let's see, 1 squared. So I think our A is going to be 3, 3x. And then I think our B is going to be radical 5. You just want a regular 5, right? Uh, just note that in the rule, uh, it should have been the square root on the left, but because addition is commutative, you can switch it around a bit. So my A is going to be 3, and my B is going to be radical 5. And also, don't forget we took out a 2. So it's going to be 1 over B. One over AB. So it's A is 3 and B is 5 times tan inverse of AX. A is 3x, and my B is radical 5. Let's see. And then you multiply this by 2. So this is going to be 2 over 3 radical 5 tan inverse 3x over alpha 5 c. And then don't forget, we have this x squared on the other side. Okay, so that's your final answer. Okay, move on to example 7. Evaluate this. Let's see. Okay, this one's a little bit different. There is a 1 on the top. There is an x here, and then times by square root. So that is one of your uh, that is one of your I think it's one of your half angles. Yeah, so that's going to equal to 1 over b in inverse of the absolute value of ax over b plus c. So the key is there's an x on the bottom, and then there's a square root, and then there's a minus here. So that's why I'm using this rule. X square root. And what number squared gives you 4x squared? So that's like 2x minus, and then what number squared gives you 1? 1. So our a is not the x, it's the constant of 2. And my b is 1. And you put in the formula 1 over b, you can inverse of absolute value ax for b, c. Okay, so we have our b, we have our a, we're good to go. It's 1 over b, which is 1, seeking inverse of the absolute value of a, which is 2x. My b is 1 plus c. 1 over 1 is 1, so your final answer could be secant inverse. There you go. There's your final answer. Okay, let's move on to example 8. Evaluate the integration of this. There's a, let's see here. There's an x, and then there's a square root, and then there's a minus in the middle. So I still believe we should use the secant inverse, right? Still believe it's going to be 1 over b. And the thing is, I got to make this 1, right? This should be 1. This should only be an x. So I have to get rid of this constant 3 and 4. You can do that because it's the constant, so you can factor it at 3/4. So now you're left with the 1 over x square root of 9x squared minus 25 dx. Okay. Okay. What number squared gives you 9x squared minus 5 squared? So yeah, I think this is going to be 3x, and then 5 squared is 25. Good. So I believe my a is going to be 3, and my b is going to be 5. B is 5. The inverse of a is 3x over b, which is 5. Let's see. Put it all together. 3/4 times 1/5 is 3 over 20, secant inverse that to the value 3x 5 plus c. Right, not too bad. Okay, let's move on to example 9. We have the integration of 1 dx over square root of 1 minus square root of x plus 1 squared. So let's see, there's a 1 on the top. On the bottom, there's no x right here. And then there's a square root, and then there's a minus. So there's a good chance I'm going to use 1 over a, then inverse of ax over b plus c, right? Okay, so it's going to be, I'm going to rewrite it as 1 minus something something squared. Okay, so this one's a little bit trickier because of this x plus 1. So my b, this is your b value. So what number squared gives you 1? 1, right? So your b value is 1. And then over here, this is parentheses, b x plus 1. So I think it's just going to be 1 and then whatever this box is, right? So be careful. I think this is just a 1 and then this is squared. So I believe our a is going to be 1 because there's like nothing in front of the x plus 1. So yeah, that's why I think our a is 1. And I think our x is, our a is 1 and then our x is this whole thing, it's plus 1. So be careful. Okay, so it's going to be, there you go. So we put in the formula, so it's 1 over a, which is 1, the sin inverse of ax. A is 1, our x is x plus 1, over b, which is 1 plus c. So 1 over 1 is just 1, and then this is going to be sin inverse of x plus 1 plus c. Okay. Let's move on to example 10. Example 10, we have the integral of dx over parentheses x plus 3 squared plus 4. Let's see, there is no square root in the bottom. There's a 1 here. There's a plus in the middle. So I think we're going to use the tan inverse. So we're going to use 1 over ab, tan inverse of ax over b plus c. Okay, so we'll rewrite this as the integration of 1 over, careful, I think our a is still 1, and I believe this whole thing is your x. So remember it's ax squared. So our a is 1, so it's going to be 1 and then our x squared. Our x is the x plus 3. I mean x minus 3. Right? And then plus b, what number squared gives you 4? 2. So our a is still 1 and my b is 2. Okay, and then put it in this formula. So it's 1 over ab. A is 1, b is 2. Tan inverse of ax. A is 1, and our x is x minus 3, and our b is 2 plus c. When you put it all together, you get 1 over 2 tan inverse of x minus 3 over 2. Let's see. Okay, let's move on to example 11. We're almost there. It's like 13 examples. We have the integration of cosine squared 3x dx. So there's a cosine square x. So there's a good idea that one must use the half angle identity. So what is this half angle identity? It is uh, 1/2 plus 1/2 cosine of 2ax dx. Right? So if you look at your rules, this is what this equals. Okay, so it's going to be the integration of 1/2 plus 1/2 cosine of 2 times ax. So it's 2, and I think our a is 3, right? Our a, this is your a value, so it's going to be 2 times 3. Yeah, so you're taking, it's 2 times the ax, so our a is 3. So when we simplify that, that is going to be 1/2 plus 1/2 cosine 6x dx. Okay, and then take the integration of each term. So the integration of 1/2 is 1/2 x. And then over here we have a 1. So be careful. So we're just going to rewrite it. So we have two integrate. I kind of did this in my head. So what's the integration of 1/2? 1/2 x. Over here, let's just to be on the safe side, let's just rewrite it as the integration of 1/2 cosine 6x dx. Let's see, this is a constant 1/2, so you could take that out. And what else? What is the integration of cosine 6x dx? Well, it's going to be sin of 6x, and then you divide it by 6, or the derivative of 6x, which is 6. And don't forget, we still took out this 1/2. Okay, so your final answer is going to be 1/2 x plus 1/2 times 12 is 1/12 of sin of 6x plus c. Let's move on to 2 more examples and we'll be done. Uh, Example 12, take the integration of 1 over 1 plus cotan squared q theta, d theta. What do we know? Because does not look one of our rules. So you're going to have to use some trig identity. And we know that one of our Pythagorean identities is this. 1 plus cotan square of x, or you could use theta, equals cosecant square theta. So you can replace this whole thing with cosecant, but we have 2 theta, so it's cosecant 2 theta. So it's going to be the integration of 1 over cosecant square of 2 theta d theta. What else do we know? Well, we also know that, I know that 1 over cosecant, just regular 1 over cosecant theta is just sine theta. And then we also, so if we have 1 over cosecant square, it's going to be, or 1 over cosecant square 2 theta is going to be sin square of 2 theta. Okay, so we can rewrite this as the sin square of 2 theta d theta. Now, this is one of our half angle identities, right? So we know that going to equal to 1/2 minus 1/2 cosine of 2 times 2 theta d theta. That's going to equal to 1/2 minus 1/2 cosine. Our a is 2, so it's 2 times a, which is 4 theta. And then we can start taking the integration of each term. So you can separate into 2 different integrations. 1/2 d theta minus 1/2 cosine 4 theta d theta. And what else can we do? The integration of 1/2 d theta is 1/2 theta minus, this is a constant, so you could take that out. And okay, so what do we know about how do you take the integration of cosine 4 theta? Uh, it's sin of 4 theta divided by the derivative of 4 theta. So what's the derivative of 4 theta? 4. And don't forget, we took out a negative 1/2, right? And then don't forget the plus t. So our final answer is 1/2 theta minus, what's negative 1/2 times 4? That's negative 1/8 times 4 theta. Plus 2. Okay. Let's do the last one. So example 13, the only difference of this one is we have boundaries. So we have the integration of 0 to pi halves of cosine fourth x all over 1 minus sine square x dx. Okay, that looks nothing like our identity, so we kind of have to manipulate it by using our trig identities. So what do we know? We have a 1 minus sine square theta, so I know it's related to our Pythagorean identities, right? And I know that the sine square x plus cosine square x equals to 1. And then I somehow have to make this into a 1 minus sine square theta. So maybe if I subtract sine square x, this cancels, and then you're left with cosine square x equals 1 minus sine square x. So now I believe you can replace that with cosine square x. So we can rewrite this problem as the integration from 0 pi over 2 of cosine 4 of x, or cosine x 4 times it by 4 times, that's the same thing, all over cosine square of x dx. And then what is cosine 4x over cosine square x, cosine square of x? That's like subtracting, because it's like saying, it's almost the same things like x over 4 over x2, right? 4 minus 2 is 2. That's exactly the same thing as this. That's going to be 0 to pi halves, and that's going to be cosine square of x d of x, right? Now this looks like one of our half angle identities, so you can rewrite this as 0 to pi over 2 of 1/2 minus 1/2 cosine of 2x dx. So what could we do? What you could do is you can literally break it into two separate integrals. That's perfectly fine. So this would be uh, what's the integration of 1/2? It's 1/2 x. And then don't forget you have boundaries minus over here. If you take the integration of this, you could factor that minus that constant 1/2. And then you have cosine of 2x d of x. Okay, and then what's the integration of cosine x 2 of x? It is sine of 2 of x divided by the derivative of 2x, which is 2. And then don't forget you still have this, you took factor out in this negative 1/2. So that's going to be negative 1/4 sin of 2x. And you could bring this, you could put this into one single. You could do the boundaries all at once. That's what I meant. And then, yeah, we could go from 0 to pi over 2. Okay, not too bad. Now you just plug in your upper minus your lower boundaries. So it's going to be 1/2 2 times pi over 2 minus bracket. This would be 0 minus, I'm kind of doing this in my head. What's 1/2 times 0? 0. Sin times 2 times 0, sin of 0 times, sin of 0 is 0 times by negative 1/4 is 0. Okay. 1/2 times pi over 2 is pi fourths minus, going to be sin, and then the 2's cancels. What's the sin of pi? It is 0. So your final answer is pi over 4. Okay, so yes, that wraps it up for that last for this section. So I'm going to stop right here.